tyFlow Basics, the script operator explained, part 2. Enjoy. Just a quick recap of part 1 of the tutorial. We learned that a comment line looks like this. We learned how to create variables and that they're a placeholder for some sort of data that you want to store. The main three kind of variables that we would be using would be integers, floats, and strings. We learnt about looping, and that's powerful for stepping through particles. And we also learnt that there's going to be a time where we're going to need some sort of test conditions for testing particles against various tests we create. We also learnt that there's 3 or 4 main methods that are part of the tyFlow API, and the main one that we're really probably going to use is this simulation step, which is where everything that's in this function is executed every time you navigate through the timeline. We also learnt that you can do powerful debugging by using the built-in tyFlow print function, and it has a limit of only printing 100 per step. There is an option to get around that with print all, but this is an example of debugging a printout that I've created for one of my flows. Important distinction I should have made in part 1 of the video, and maybe that's my lapsadaisy Australian. There's quite a difference between a single equal and a double equal. Alright, so when you're doing testing of any kind, a double equal means compare to the value on the right. A single equal, like here, right, is an assignment. So, you know, for example, integer I equals 1 means I'm assigning the numeric value 1 to I. Up here, I'm comparing I to 1. So just be aware that a single equal sign and a double are not the same, and you really need to watch that when you're doing your coding. Also, when we did the video, I kind of had a couple of cases where I had to kind of reevaluate the script all the time, and by accident I kind of figured out why that's happening. It's got to do with the cache and being enabled, and I'll show you that in a second. As far as, you know, I said we need to touch on a lot of C, and C is part of it, C++. Well, in tyFlow, I went through all of his API and found all the different data types he has. And this is it. I think the count is 15 as of, you know, June 23. And that means that, you know, there's a lot of things we don't have to learn. You know, we only have a few variable types, you know, as far as floating point, Boolean, and integer. They're the main ones that are really used throughout his API. Obviously, there could be a lot of maths involved in point 3 and matrix data. And apart from that, you know, we can limit our learning by realizing that these are all of the various tyFlow types he has, and so don't go running off and learning how to, you know, code to recreate the universe. Let's show this caching thing. So I've got a flow here set up, and it just starts from frame 152 as far as updating, and you know, you can see that the flow isn't really updating. And if we go in our tyFlow, and you can see the blue line is cached, right? From frame 152, my script should have been putting out some text saying debugging. Now, if I reevaluate all, it'll end up, I have to go in my tyFlow. If I go in the script, and reevaluate, then it'll end up debugging my text. And earlier I said that every now and then you just have to do that. Well, like I said, I figured out why it is. It's because if you're in the cached section part of the flow, it's not going to update. So if you're doing a lot of debugging and stuff, if you disable this enable playback cache over here, it'll update your script all the time. So you may remember to turn it back on later, or you're going to slow down your flow creation and everything. But just now you can see it's always going to update. So if your Max script listener isn't showing what you're expecting, it could just purely be because the caching. So keep that in mind, and let's start part 2 of this tutorial. Let's talk 2 other things before we start to dissect some of the example code, create our own code, and figure out how to get from this kind of information or spaghetti to this kind of spaghetti. First one is debugging. So if you look at these 4 lines of code here, and then you look at the output here, alright, you can see that you need to be able to use this print statement effectively. tyFlow doesn't really have the kind of debugging options that you would, for example, in Visual Studio. So your main debugging tool is this, as well as some options under the settings in tyFlow to print out, but it's really, I think you have to learn how to create this kind of information for yourself to print out to the Max script listener. And if you notice here, you can combine things and you can build a text. So here I'm saying I'm printing the matrix 3 data for my box A, and so this is the text portion of it, and then I'm adding the variable portion, and when you see the result over here, that's the printout from that line. So if I'm printing out a lot of things, that makes it easy to look at what it is I'm printing. So if you just kind of, I'll try and put them both on the same page here. If you kind of just look at these 4 lines here, and then the output here, right? And that's really, make sure you do some playing around and testing on printing. Now the other one that you should try to make sure you do is good formatting of your code. So for example, if we do a for loop, right, and so there's an example for loop, right? Now, as you get more deep into programming, you're going to do more nested stuff, all right? And so make sure you kind of keep your indentation, right? So that you can programmatically see what belongs inside what, you know? And I'll show you what I mean in a minute. We'll just copy that to make it speedier. Now, you don't want that there. You want to indent that in, something like that, so that you can see and follow your code later, right? So just from the beginning, learn to have great formatting in your code. And of course we can't have 2 Ks, so I just make it L. But anyway, do proper formatting and do great indentation. Really play around with this printing for debugging, and let's try to dissect some code, look at this script accessible objects, script accessible text maps, this float option here, but even there just going in and making our own code. Alright, let's talk a little bit about the tyFlow class. If we kind of look here, I've just got it organized in this file so we got easy access to it, but these are the set methods that are part of the tyFlow class, and I'll just zoom that in a bit for us, right? So when we're looking in here at 3 set methods, we'll just go a little bit more in value, in detail. We got set custom float, set custom TM, and set custom vector. So these 3 methods access the custom properties files that you create in your flow. So when we look over here, you know, you got your custom properties over here. You know, those member methods can access that. So first of all, let's just have a look here. And these are member methods of the tyFlow class. So without kind of trying to get into heavy detail about programming, you know, a class is just a data structure, and it can have all sorts of member methods, member variables, and think of it as a way to organize data. And to access those member variables and member methods, you need to use the dot operator. So if we kind of go over here to our blank script, I got one that just has the methods in them so we got easy access to them, and then I got a blank one here, right? So if we actually want to access that custom float method, let's say we only want to do this if the frame number is greater than 1, right? So there's our first line of code, and we're using one of the basic tyFlow variables, F for frame, and we scroll down here and do the curly bracket. So now everything inside this function is going to happen on frame 1, greater than frame 1, right? So TF, that's the tyFlow class, and we wanted to access a member variable, which we're going to do set custom float, and it requires 3 parameters. The first one being the particle ID. For now, I'm going to manually enter one. We know we have 3 particles being born over here on frame 1, right? So I'm just going to manually enter the number. It also needs a string, which is the name of the custom float file. So my custom float file is called float position Z, and it has to be exact what you've got in this custom properties over here. So you can see I'm doing Z data, but that's irrelevant. We're just doing an example of storing and manipulating data in a custom float file, and you can see here that it's called float position Z, so you make it exact, and then it requires a value that we're going to put in that custom float for that particle, and we're going to put 2.0. Remember about typecasting, we have to typecast it to be a float so that tyFlow doesn't spit out an error. And then we're going to also access another one where we're going to get the event age. So it requires a float as a return, and we're just going to call it F particle, see if I can spell right here, particle 1 event age. And to access that, we just got to do the tyFlow class and then dot get event age, and again we're going to manually for now put in the particle ID number, right? So if we look at this a little bit more in detail here, all right, So if the frame is greater than 1, do what's in this curly brackets. And we're accessing the tyFlow class because we want to learn how to use the tyFlow class. So we need the TF to precede any members and variables that are in that tyFlow class of the API. Alright, and then we can access, the member methods. And some member methods have return types, and all of them have some sort of parameters. And so it's up to you to create and type those parameters. So the TF set custom float, the set one didn't have a return value. That's why there's nothing preceding on the left here, no code. But the get event age does have a return type, and it was required to be of type float. So we fulfilled that requirement by creating a float, and we called it fParticle1 event age, and we're going to return the age of particle 1. So if we look over here in this example window, and we can evaluate that, and if we scroll through our timeline now, right? So particle 1 is one of these 3 spheres here, and I've got here pre-configured so we can see the data easily. And we're seeing data for ID 0, and we're seeing data for ID 1. So initially you see that what was stored in the custom float over here is 0, right? And when we get past frame 1, our code up here is going to take action, and it's going to try and put 2 into that custom float file, and that's what we're looking at here. And you can see that on frame 2, all of a sudden now our custom float file here is showing 2. So right there we've manipulated the data in a custom float file. So that kind of shows you how to use those TF class methods. It's kind of all the same. If we scroll down here, I got some of this, these are all the set ones, and then we scroll down further, and this is the get ones. And if we zoom in a little bit here, so these are going to get data instead of setting it, right? And whenever we're getting data, for example, we're going to have a return. So for example, if we want to get the age and we want to use this member method, we would precede it with tf.getAge, and then we would put the requirements in here, and then we have to know that it's going to return a float. So we would write code that accepts a float value so that we can get and use the age of the particle. And for example, if we want to get the ID of a particle, right, it needs a return type of type integer, right? And to use this getID method, we need to precede it with the tf.getID and provide the value. So for example, if we want to get the ID of particle 1, right, and sometimes they'll be different, which is why it's better to use the simulation index and actually loop through them, but we don't need to do that for this small example here, right? So, you know, if I remember right, it's kind of here was integer, I think, integer part ID equals tyFlow class dot get ID, and we required a particle number. We do 1 and return, and it should evaluate, right? And for us to see what that returned, we would have to print that out to the max script listener, in which case you would just print out a print statement like we showed earlier. Now, we probably, unless you saw my custom properties tutorial, you probably need to quickly revisit matrix and vector data, at least be aware of how it's formatted, because that knowledge is required to get the data, right? Because you're going to get 0.3 data and you're going to get matrix data and you're going to manipulate it. So you should at least be aware of that. We'll quickly go through that now. If you want more detail, go back to the custom properties tutorial. Let's do a quick and dirty revisit of matrix tree and vector data. If you want a more full-on in-depth description, go see the custom properties tutorial. Let's shrink these for a minute and come in here and go to here. Alright, so this is matrix data, right? So, this is a matrix data set, and X value or X data here for rotation, scale, everything like that, except for position. Position information is in the last set of brackets, and that would be X, Y, and Z position information, right? And this would be Y matrix data, like for scale, rotation, blah blah blah, anything but position, and Z. And one of these sets of three is kind of vector data. So when we're manipulating individual data, and we'll do a quick example of that right now, of manipulating some data, we would be manipulating these sets of bracketed information, which is why we need to know a little bit about vectors and matrix tree data. So let's do one final code example before we move on to the TF object class. And we'll bring back this stuff and we'll go to this window here. And because we talked about matrix and vector data, now I'll show you how it becomes relevant. So what we'll do is if the frame is equal to 2, alright, so remember double equal is comparison versus a single equals assignment, curly brackets to designate the if, and anything in between. So we'll do a 0.3 for, that's what we need for particle scale, right? So we're going to scale particle 1. So I'm just going to call it particle 1 scale. And that defines a variable of type 0.3, and it's going to be one where we're going to mess with the scale of particle 1. So we've given it that name. And just to make things easier here, I'll copy this for a second. Control C, Control V, and now we're going to access the X value. And we're going to leave it at 1. And we're going to now do the X, Y, and Z. So we're assigning values to the X, Y, and Z. Control C, Control, oops. So X, Y, and Z. And we're going to mess with the Z. And we're going to make it 1.5 in scale. And remember, we need to typecast it as a float. And now we need to apply that to our particle. So we need to use a set method, which is part of the TF class. So TF, right, set scale, and it requires the particle ID, and we're going to use 1 for now, and it needs a 0.3, oops, it needs a 0.3 variable, and it's going to be particle 1 scale. And now we should be able to manipulate our particle directly. We go back here for a minute, shrink that down, go up here so we can see our animation, and we go through. So it's only going to happen on frame 2. So on frame 2 we set the custom float value for particle 1. We didn't do it for particle 2, and file evaluate. The error here is that I put 2 dots instead of semicolon. Right, so now when we evaluate it, everything is good. And when we go back here, and now we jump to frame 2, you can see that one of the particles here is changing in scale on the Z. So that's particle 1 that's being manipulated here. And if you look carefully at our matrix data here, right, we can see, when I talk to you about the matrix, we can see right here that we've manipulated that data in the Z. Remember, this was X data, this is Y data, and this is Z data, and this is position information, right here. So you can see the 1.5 that we put in our code over here has now manipulated that particle and changed its height. So I hope that gives you enough information to play around with the TF class, and let's look at the TF object. Alright, if we look at this test setup here, we got 2 boxes in the viewport. The big green box is a mesh that I want to reference in MaxScript. The purpley blue box, the smaller one that's selected, that's like a test box. I'm using it to perform script test. Now, to access either of these boxes in script over here, we need to add them to this script accessible objects list. And that's as simple as selecting your box and then add selected, and you can see that I've added 2. The small blue purpley one is called box test, the large green one is box A. And box A is really what we want to write the majority of our code to, or when we're doing this tutorial, that's kind of for this test purpose we're going to do. So I've got 2 objects. The first one here, all I'm doing over here left in my script window is I'm creating a TF object so that I can reference it in code. I'm calling it my box test, and it's referencing object 2 in the list. So that is my test. And all I'm doing with that is constantly getting the position of it, all right, and putting it into this position variable here. As far as my object that I really want to do my scripting on, this is the object 1, which you see over here, box A. And you can see right here in script, I've created a TF object called myBoxA that references object 01. Now I can access things in this mesh by going through my box A variable. Now, how did I know how to write all this code or whatever? Well, you kind of look at the API here and you see that this is like a huge block of information, and it's a lot, and it's kind of hard to dig through and get what you want. Now, I spent a bit of time and created this diagram. Now, I'm not 100% sure. I haven't checked every single thing in it. I think eventually I'll release it. But as far as the box and the TF object class, this is everything broken down that's in that TF object class. So if we look here, originally we got our box A mesh in the 3ds Max viewport. We add that to our reference list of our accessible objects. Now in MaxScript, we create a TF object called box A. Now, because I've now created this TF box A, I can access all the things that are in the object class, which is somewhere in the middle of all that API text, right? This is why I've kind of spent a time making it more visual. And in that TF object class, we have, you know, TF face, we have the mesh, and once you reference the mesh, you get access to all of these things, right? And some miscellaneous ones, some 0.3 stuff, matrix data. So for example, if you're following through and say, okay, because we've created our TF object box A, now we can call one of the methods that's in that class, which one of them would be getTM here, and there's an example of code right here. And now because we've done that, we can dig down further, and now we can get .3 information and all that kind of thing. So if you pause the video, this would be a more visual representation of that tyFlow API. Now it's not all of it. I'm going to probably need to do a page 2 and 3, but this is all of it as it relates to TF mesh stuff and TF object stuff, which is the subject we're doing right now and referencing through this rollout. So if you just look at my example code over here, you can kind of decipher what's going on, and I've got it commented pretty good. But here is a set of tests I'm performing. And so the first thing is create our TF object. Now that we have our TF object, we can access other values through that TF object, and if you follow the logic of the code, you'll see it. And then I'm going down here a little bit, and I'm going to print out some test data here. Alright, I'm going to print out some test data here. So if we come over here to our Mac script and we evaluate that, you can see here, this is the result of the printout. So what we got to do now is kind of play around and create our own variations or our own code, but I'm trying to explain this script accessible objects and this API thing. So again, don't forget that you can have a more visual look at here, and in each one of these there's codes, examples, and you can kind of get an idea of how you can kind of tunnel right down through and get, you know, the most finite of information that you might want to use for your script animation or particle testing. I mean, I can't create the wonderful graphics for you. This is about learning how to code in tyFlow to kind of create your own amazing stuff. And let's move on to now actually trying to do some tests and stuff with this. So let's step through the process of doing the script accessible objects. So first thing we'll do is add our two objects to the script accessible list. So we select the box, add selected, we select the testing box, add selected. Alright, now we can go into our script editor. So I didn't rewrite the code here. This is, don't worry about up here, but this is where we're going to write code in the simulation step. And rather than redoing it in front of you, this is just code for my test box, and it puts the position information of my text box into this variable continuously, so we can do tests against this box. So now we're going to create the code for our TF object, right? So we're going to create a TF object reference. So we're going to do TF OBJ, and we're going to call it myBoxA, and it's going to equal OBJ001, which is what's in our list, right? So if we evaluate that, we have good code. It didn't come up red, and when we go back here to our tyFlow window here, you can now see that in code we've given ourselves reference to this box A. Now we want to do something with that. We want to, for example, go over here and, for example, test. See, I've got this polygon selected. So I'm going to turn it back off. So we're going to do a few tests and say, is our test box the closest to this selected face? And some other tests in code. How would we go about that? Let's put, I've created these little buttons down here. So now my test box is as close as it can to this face so that we can write code and see how we would go about doing that. So this is essentially when you would use this API. You've created this TF object, myBoxA. Now you want to know what you can do with it. You go into the API here and you scroll down. Eventually you'll find this TF object class, and it's right here. And these are all the things that you can do with it. That's looking at it that way. If we go to my more visual thing here, you can see we have now access to all of these methods here and tests, right? The one we want is we're going to test against that face. So if you look carefully here, the choice here is TF face get closest face, and it requires a 0.3 value, which is a point in 3D space. If we go back and look here and write that code now, so the return type was a TF face, right? And we're referencing it through myBoxA, so myBoxA, and to make the naming conventional easier for me, I'm going to call it face, and then I'm going to say equals myBoxA dot get closest face, and it requires a 0.3 value. Now earlier I had created this automatic position updater for my test box here, so I'm going to use the variable here, which is a 0.3 value, and I'm going to put that in my method here and finish it off and new line, and that should be a functional line of code. I hope if we evaluate that we don't have any errors. So now the closest face is being returned and being put into this myBoxA face value variable, right? So if I wanted to say print that result, I could now do a tyFlow print so I can see what's going on, and I'm going to say print closest face plus myBoxA underscore face, there, like that. So what I'm saying here is print, put some text in there first, then add the result of this, and let's see what it prints out. Let's first of all see if it evaluates. It evaluated, and you can see right now it says TF the closest face. That is TF face. So I kind of did that on purpose, right? Returning TF face as far as printing it out isn't really a usable thing, but it gives us access to more. Like, we want access to the ID of that face so we can do some sort of test against it or whatever. So if we go back here to look at my visual one rather than digging through the API, we can see here now that we use this TF face class, which now gives us access to these TF face items here, right here, and we want to get the ID, right? So if we look here, get the index of the face on the mesh, so we can use that one for example, right? So let's do that. How do we do that? Okay, so we have our TF face here, and integer box a face underscore ID equals my box a underscore face dot INX end. That's what it told us to do in a library. If we evaluate, we don't have an error. Now we need to see the result so we can know if that really happened, right? So now if we do another printout, and I'll just take a shortcut here and copy that down, Control V here, and change it to say closest face ID, and now we need to put this value here as the printout to see if it's going to return an ID for us for that face. Control V, and let's evaluate that, and hopefully it passes, and it does. And you can see here we have a face ID of 11, so our test result is happening, right? And I've created these little 3 script buttons down here. Let's put our test box on top for a minute. So now I'm putting my test box on top, and the closest face would be this top one, right? And you can see how that changed over here. So now it's telling us that the face ID up here is 2, and if I put it on the right here on the side, now it's telling us the face ID is 5. So there's your first example code of performing some sort of test using this script accessible object, and obviously if it was a real coding example, you would be doing some sort of testing of particles against things and then making something else happening in script. But there's our first kind of bit of code, and let's keep going. Just to finish off on this section, originally we were in here and we said we had this face selected, and what would we do to say do a test? Is our box, is that face selected, right? So going back to my code here, and I've just commented it out a bit better for you, right? If we look at our API in the TF face thing, and we come down here, you can see right here is a thing here, bool, returns a boolean, and is it selected, and it says get the selection state of the face. So here in code we need a bool return, right? And we'll call it B is face selected, and it's going to equal my box A underscore face, and then in the API it says we use the selected keyword, right? And that should return that status as a true or false value. If we evaluate that to see, well, we didn't have any problem, it evaluated good, but we also need to print that out. And so we go in here and create a new print statement, Control V, and face is selected, and we want it to print our Boolean result, Control C, and we come down here and put that in here, Control V, evaluate that and see what happens. Evaluate, and it says the face is selected equals true. So we go back here so we can see what face is selected. You can now follow the code through and how we got to a point where we were testing this face selection box against this, right? Now because we moved our box away from that face that was selected, right, and it's on top, the result is false. Same as for right. And we move it back in position left, and now you can see how in code we're achieving these test results. So I think we'll leave it there as far as that, but I hope you followed the structure through on how we can decide what we want to do and then use this API to get the results we want. So I've cleared all the code that we wrote before in the simulation step, and let's look at this floats rollout. So why would we want floats over here when we can define them in code? So let's call this my float rollout, and we'll give it a value of 1. And we come back over here in code for a minute, and let's do a hard-coded float value. So float my float 01 equals 2.51, comma, end of line, and we think we've created a float, right? We evaluate and we go, oops, nope, we didn't. And what's it telling us there? It's telling us in the debugger that we cannot implicitly convert type double to float. So that's because tyFlow assumes that decimal values are doubles, but we really want float values. So the way that we do that is to typecast the value by putting the F there, and that tells tyFlow that you want this to be treated as a float. And basically you can think of a double and a float. You can think about the double being twice the value of a float. So a float is a small decimal, a double is a large decimal, but you do need to typecast them. Now when we evaluate, everything's okay, and we have a float value. And if we go in now and do a print function to the Mac script listener, and we create a starter text to say my float from script value and space, so we have room for it, plus what do we want it to show as well as the string there? We want it to show my float 01, and that should be a functional line of code. Hopefully we don't get any errors. Evaluate, everything seems to be good, and you can now see down here that we printed 2.51, so it accepted our hardcore value. Now why don't we just use that instead of say coming over here, and how do we access this over here in script? Well, access to that float. So we'll say float my animated float equals get float, and we want it from my float rollout. Alright, so my FLOAT rollout, and it requires a second parameter. I'll just do the frame and do that, and we should be taking the value that's over here in the floats rollout, putting it into this animated float, and if I spelt it right, we should have a functional line of code. Let's see if we do. Evaluate. Column 36, new line constant. File evaluate. 11. Oh, I forgot the semicolon there. Sorry. Evaluate. Now we're good, right? And so if we come back here now and print that out so we can see what gave us my float from rollout, and we want it to show that there, so we'll just Control C it and come down here and Control V it, and let's see what we get. Evaluate. We get 1, which is what we got in our rollout. Alright, and we're doing it on the frame number, but let's just say print it at hardcore frame 0 and evaluate, and we get 1, right? So what if we were now to animate this value? So if we go into 3ds Max and set an auto key and say go to frame 5 here, and let's put 5 here, enter, we can see we get this animated red square around letting us know that this value has now been keyed, right? So when we go back and forth, you can see that the value changes. And then we go out of that so we don't do any more animation, and if we see our result, it always says 1 because we're looking at frame 0 up here, right? So if I now change that to say frame 4 and evaluate all, you can see it shows 4.584, and we go up here 4.584. Now on this getting the values from here, there's actually 2 overloaded functions. Let me pause and find it in the API and I'll come right back. Alright, I'm back, and what do we mean by overloaded functions? Well, what it means is that the same method here, get float, normally you can't have 2 called the same name with 2 different variable requirements unless you create like an overloaded method. So in other words, the same method here can be done 2 different ways. One, it can just get the float from our rollout over here, and on another it can get the float and from what it says here is a frame number, right? So let's just utilize that overloaded, right? So that means we could also come over here, and we'll copy all this for a minute, copy and paste it. So we'll just call this my animated float B and get float, but we won't do it with the second parameter now, right? So we're still getting the value here, but without a frame number. And now we need to print that second value. So we're going to call it my float from rollout value, and we'll call it B here, so we know the difference between the 2, and my animated float B. Now when we evaluate and look down here, we're still at frame 4. You see we get 2 returns. One is 1 and one is 4.584. And if we look at the text description here to the right here, you can say that the first get float always returns the value from frame 0. On the second one, you can return the value from the frame number. And if we go up here, you can see there's also a floating thing that's the current frame. So when I originally came back here and used that tyFlow API F, that returns the current frame number automatically as a float, which is what required there. So now if we evaluate, right, this will actually update the value to match what's in here every time we run the script. If we clear this for a minute, go to frame 0 for a minute, you can see value B is always returning 1. Alright, clear all. But the one that's referencing here with the frame number is returning the animated value. And just run that and you can see that all matches. So to answer the initial question is, why do we have this floats rollout? It's really so you can do animated values, and you can do them in a much easier way than trying to hard code it. You can just come in here, type your value, go and set your keyframes, animate the range you want, and then you've got easy access to an animated float value. So I hope that covers this float rollout and how to use it. If we just went in here and tidied up our code a little bit with some comments, right? We'll just say here, we're getting a float value from the floats rollout and updating per frame. That would be the right description for this next line of code. And down here, and I'll just copy the comment, put it down here, Control V, and what's really happening here is we're always getting a value from the float rollout on frame 0, right? On frame 0. So that's it for the floats rollout and how to use it in tyFlow script code. Alright, this is an example of what we'll do in part 3 with script. Have a good one. See you then.